Good evening and welcome to EDX 3160, assignment 2. And today we're going to be looking, or this afternoon, we're going to be looking at solids, liquid and gases. And we'll have Joanne here to help us, focusing in mainly on the solids and what is a solid. Alright Joanne, we have our solids here. Can you actually have a look at the observable properties and list them down here for me please?
Okay, well, solids, they're hard, see, they're hard.
Yes.
See this, they have shape, see this is in a rectangle shape, but this is all, they're all different shapes. And they also have volume, but they do not flow.
Okay.
And then when you got shells, see, different shapes,
Yes.
different sizes. They also got a hard, but if I went to break it, they would snap because they're also fragile. But they also have, I said they have shape, they have volume, and they do not flow. And then with biscuits, yummy.
They're hard as well.
They're hard. They have a bit of volume around the edge. They have different shape. They're obviously different shape to the shells, different shape to the rocks. They have different shapes.
All right. If you could list those properties down for me, please.
So they're hard.
Yes.
They have no. Oh, I know they have shape. Sorry.
That's all right. No, that's all right.
They have
Good girl.
shape.
You've picked that up.
They have volume, and they do not flow.
It's always good when you make a mistake because you've gone back, you've thought about it, and you can see where you've gone wrong. All right, let's have a look at your liquids now.
Okay, well, the oil, it's thick. See,
Yeah.
it's thick. It's thicker than the lemonade.
Yeah.
And it does flow. See, look, it flows smoothly up and down the container like that. But it has different shapes. See how this the oil conforms to the bottom of the container.
Yeah.
So it has this orange. It has this circular square shape. And then when you flick it up this, it turns into a bit of a cone shape.
Good girl. All right.
And then
what about your other ones here?
The milk. When I pour the milk into the milk jug, it's changing shape. It's more of a
Fits the container, doesn't it?
Container. It flows. It holds volume.
Good girl.
And then with the water, the lemonade.
Yeah.
When you pour it into the cup, see, it flows.
It's changing.
And
It's
it's
filling the
changing
container.
shape, and it has volume.
All right, Joanne, can you write those down for me, please?
Sure. Oh, and it's not hard.
No.
Because it
all
can
right.
flow.
Okay. Good girl.
So, not hard, no shape, has volume, and it flows.
All right. And our last one, we've got our gas.
Okay.
So tell me a bit about our gas properties.
Well, it's not hard because it's a bit squidgy.
Mm-hmm.
It has no shape because this is more of a oval shape, and balloon animals, they can be put into different shapes when you tie them up.
Yes. Yeah.
So, it has no shape, it has volume, because if we put more gas into it or more air into it, the balloon would get bigger and bigger.
That's exactly
and
right.
the air flows because all air flows.
It does. Good girl. All right. So can you list those down? All right. Now, writing's a bit wonky there,
Yeah,
Joanne.
it is. That says flow, so
right,
I'll
good girl.
fix it up.
That's all right.
Close.
Now that you've got your understanding
Okay.
of the solids, liquid and gases, now we're just going to come down a bit. We're going to focus on, firstly, what makes a solid a solid?
Okay.
What's the difference? Well, before we answer that, what's the differences, two main differences between your liquids and your solids?
Okay, well, the two main differences is that one has shape
Yes.
and one doesn't have shape. See?
Yes.
It changes shape. So
That's
you can't
correct.
say this is one shape, but this is one shape. And then one flows and doesn't flow. So as I said before, you can actually see the oil flowing
Good girl.
down the
Yes.
container. Oh, well, if I did this, or nothing changes.
So that leads me into my question that I asked you before.
Okay.
What actually makes a solid a solid? Your concept, your whole idea of a solid.
Yeah.
What do you think?
Is that particles? Something's got to do with particles being.
It does.
Making up the.
It's the inside bits.
Yeah.
Right, I'll just draw you something. I'll show you something that's actually inside any solid. This is any solid, all right?
Yeah.
So I've got these tiny little, as you said, particles, and see how close they are together?
Yeah.
You can't...
They're very close together.
They're jam-packed.
Yeah.
They're so jam-packed tight that their movement, they only vibrate. So that's the concept for a solid.
Of this. That's what makes up.
So are you getting that understanding?
Yeah.
So inside that, they're tight.
Yeah.
Whereas inside your liquids, the particles inside here, see the gaps in here?
Yes.
So they actually, that's what makes them flow. They can
So
actually
that's
flow.
what makes it does this.
Yes.
Okay.
So with our solids here,
Yeah.
whether it's a big block like this,
Yeah.
a massive big boulder, or a tiny one grain of sand,
Yeah.
it's still a solid.
Okay. So it still has particles in it.
Whether it's that tiny or that big, and they're all jam tight.
Oh. Okay.
They're all jam tight.
Yeah.
All right. So today we're going to have a look at, going on all your information here, if we can make a solid flow.
Oh. But solids can't flow, like I said. Or can they?
All right. So you could have a bit of a misconception here,
Yeah.
because you've just stated that all solids can't flow.
Oh. Yeah.
Yeah?
Yeah.
Okay, so that's a bit of a misconception.
Yeah.
When we're going to do an experiment so we can actually see whether all these particles are really, really tight together. All right. So our experiment that we'll do is, we've got some biscuits.
Okay.
Oops. That's your PPE gear that you'll have to put on. We've got a plastic bag and a rolling pin, and we're going to use this shape because you know how when something flows it forms to the shape?
Yeah.
So that's our experiment today.
Okay.
So your inquiry question is going to be?
Can all solids flow?
Right, so we're going to have to prove that right or wrong,
Okay.
and that's the end of our introduction.